This is the PowerPoint presentation on solving linear equations. Now, there are some rules, and we'll take a look at them. When you see an equation, if they have a fraction, you want to multiply both sides by the least common denominator every term to clear the equation of fractions. Then we want to use the distributive property to remove parentheses or any grouping symbols. Then we want to combine like terms. Then you want to get all the variables on one side and all the numbers on the other side. Then you want to isolate the variables so it's just one x or one r or one of the letters. And then you can take your answer, put it in the original equation to see if, in fact, you end up with a true statement. That's called checking your equation. Now, here they're giving us a particular example. We know it's an equation because of the equal sign. And there are no fractions. So on this side, we're going to collect like terms. We have 17 and 3 that will collect to 20. Now on the right side, we see a parenthesis, which we want to get rid of. We're going to do that by taking the opposite of a -6, making it a +6, and then that becomes 21. Now you have on one side, again, no fractions, no parentheses, no grouping symbols. You've combined like terms. Now you want to isolate the x, the variable. So you're going to subtract 20 from both sides. When you do that, 21 minus 20 is 1. And again, you want to solve for a positive x. You do so by dividing by what is in front of the x. That's called the numerical coefficient, which is in a sense, a -1. Divide both sides by a -1. A positive x now equals -1. And if you put that -1 back in the original equation, that would solve it. Now, here's an example in which we have a fraction. And we're saying the easiest thing to do, you could multiply everything by 5. In fact, let me do that for you. So I've set it up, copied the original problem, which is always a good idea not to destroy the original problem. And there are 3 terms. We're going to multiply each by the common denominator, 5. So now this becomes a 5. Here the 5's cancel out. When we multiply, we get 3a equals 40. I'm going to subtract 5 from here. I get 3a equals 35. Now I'm going to divide both sides by the numerical coefficient of a. And I get a, when these cancel out, equals 35/3. Now, they did it another way. They took the 1 and subtracted 1 from both sides, got a 7. Then they use the reciprocal of the coefficient of a, which is 5/3. 5/3. And they show that here. When you multiply something by its reciprocal, that just cancels out and becomes a 1. And there's our answer. Now, in our toolbox for solving equations, there's always more than one tool. And here you have one technique. Here is another technique. And actually, you have the choice of what you're going to do. Now, in this example, you have a grouping symbol, and there are no fractions, so we're going to clear the grouping symbol by distributing, and we can follow it here. We distribute the 7, being careful of the signs. Now, this is often where we think of a middle step in the process of solving an equation, where we have a variable and a number, a variable and a number. One of the things we try to do is to keep our variables positive. So we're going to subtract 7 from both sides, 7x. We get 2x. And now we have x is only on one side. We want to get rid of the negative 7 by adding 7. And when we do so, we end up with a negative 14 equals 2x. We divide both sides by 2, and you get x equals a negative 7. Now, as you look at this, here is a series of logical steps following the procedure for solving an equation. And eventually you're getting a letter equals a number. Now, if you were to put the negative 7 here, that would make this a true statement. Now, here we get a more sophisticated one in which there is a fraction. And so our lowest common denominator is going to be 5. So we then wonder, well, what's our technique? Well, we're going to take this common denominator and multiply it by each term. And we wonder, well, how many terms are there? Well, this is one term. This is one term, and this is one term. So we're going to multiply this side by 5. And this method of putting this in parentheses is good, but I would suggest doing it this way. You're putting the 5 up there, put it by each term. Here they just want you to distribute, and that's a good technique too. So now the 5's here cancel out, and here we just distribute, and we get this. Now again, we want our y's to be positive, so I'm going to subtract 3y from here, and subtract 3y from there. Again, that's what they're showing here, horizontally. I also like the technique of doing it vertically. So now we get 9, and we get our, well, here the zeros cancel out, we're left with a 9. Here we do our grouping, and this becomes a 7y. Now to get rid of the 30, I'm going to subtract 30. And I'm subtracting 30 from this side. And that's what they're showing here. So now we end up with this cancels out, and we get 7y We do our addition of unlike sign numbers and get a negative 21. Now we're going to divide by the numerical coefficient of y, which is 7. These cancel out. We are left with a y, and this is negative 3. Now in this example, we have another kind of fractions. So in looking at them, we see here there are two decimal places, two decimal places, two decimal places. So 3 terms. In order to get rid of the decimals, we're going to multiply each term by 100, which causes us to move the decimal place over in each of these terms 2 places. And then we can rewrite it and we get this. So you might say, why did you do that? Well, it makes it so much easier to work with things that don't have decimals. Now we just distribute through, clear our parentheses, and we get this. So what is the next step? Combine like terms. And to get rid of the a's on this side, we're adding an a, adding an a. Now to get rid of the 4, negative 4, we're going to have to add 4. And now to get a positive a, we're going to divide both sides by a negative 4. And we end up with an answer of negative 1. Now if you put the negative 1 in this equation or this equation, it will make it a true statement. Now, every once in a while, we have something that looks like an equation, but when we solve it, go through the steps we've described, we end up with an untrue statement here. In a case like this happens to be, in a sense, a phony equation. It's not truly an equation, because for this there is no solution. And that's what they're stating here. Where it looks like an equation because of the equal sign, you worked it through, but the x's cancel out. So you're left with negative 7 equals 3. That's not true. So when you do that, this is a... Now here we see another example where it looks like a real equation, and we clear parentheses, group like terms, and then when we get to this stage, we see it is exactly alike. Well, this equation is called an identity because one side is identical to another. Now, if we subtract, let me clear it up, a 5x from this side and subtract a 5x from this side, we end up with negative 5 equals negative 5. That is a true statement. When we end up with a true statement, we have, in a sense, an identity. Now, what is the solution for an identity? Well, whatever number you put here in our real number system for x, and if you put that same number on the other side, that will be a true solution or a true equation, a true statement. So the answer is, when you have an identity, your solution is all real numbers. and we sometimes use the symbol, a double R, for it. All right, so this completes a review of the technique for solving pretty much any equation where we get rid of fractions, we get rid of grouping symbols, we transpose from one side to another to get all the variables on one side, numbers on the other. We then divide by whatever the numerical coefficient of the variable is, and then that is the solution of the equation. Now, if you get a false statement, there's no solution. If you get one solution, x equals 5, that is the solution. And if you eliminate the letters but get a true statement, these are all real numbers. And that wraps up this particular lesson.